In this video, we're going to do some problems off of page 259 in our textbook. These are examples from the material in section 6.1. In exercises 17 through 36, assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean of 0 and a standard deviation of 1. The fact that they're normally distributed and have this mean and this standard deviation means we're talking about a standard normal distribution. In each case, draw a graph and then find the probability of the given bone density test scores. We'll be using our TI-84s in this video, or a TI-83 will do the same thing in exactly the same way. All right, so number 18, we're supposed to find the probability of getting a bone density score less than minus 0.5. So we're supposed to draw a picture. I know the mean's always in the middle. So minus 0.5, it's down here somewhere. So I'm supposed to find that shaded area because we remember that the probabilities are really these areas under the curve. All right, well, I need to use a function in the calculator to do that. And that function is Normalcdf, found by pressing second vars, and then it's the second option, Normalcdf. We're supposed to type into Normalcdf a left value, and because that goes all the way forever, I like to use minus 10 to the 99th, something very far away from the mean that's so far away it might as well be infinity. A right-hand endpoint, so minus 0.5, and that's supposed to type in the mean and the standard deviation. Well, for the standard normal distribution, I don't actually have to, but I always just go on and do it anyway, and that way I never forget. So minus 10 to the 99th, comma, minus 0.5, comma the mean, comma the standard deviation, press enter, and there we get a probability. The probability of selecting a bone density test score below minus 0.5 is 0.309. All right, number 20. Doing the even problems from 18 all the way down to 30. Less than 2.33. So again, draw a little normal distribution. The mean zero's in the middle, less than 2.33. Well, 2.33 is pretty far above the mean. Right, because anything over 2 standard deviations above the mean is actually considered significantly high. So I expect this probability to be fairly high. The total area under the curve is 1, and we've shaded a lot of that space. All right, so again, where are we going to type in our calculators? We're going to go to Normalcdf. Minus 10 to the 99 again, because we're starting all the way over to the left as if we were at minus infinity. All the way to 2.33, and again, comma the mean, comma the standard deviation. All right, so back into the distribution menu to Normalcdf. 2.33 this time, comma 0, comma 1. And here's that pretty large probability, 0.990 to 3 decimal places. 99% of the bone density scores possible are below 2.33. 22. Greater than 2.33. Well, I think I could just go on and answer that by writing 0.010. That's below 2.33. The rest of the area, right, 1 minus this is to the right. But if I was just following the instructions, I draw a little diagram. Right now I'm thinking greater than 2.33. So let's just go on and use Normalcdf to make sure everything's working out just fine. So this time, I start at 2.33 and I'm supposed to go all the way to the right. So back into the distribution menu. 2.33, comma 10 to the 99, comma the mean, comma the standard deviation, 0 and 1. And there I have it, 0 point. And when I round to match that one to 3 decimal places, I get 0.010. All right, so the thought process we had before seems to work out just fine. Let's move on to 24. Greater than minus 2.09. All right, well, minus 2.09 is pretty far to the left down here. Again, 2 standard deviations below the mean or away from the mean, pretty far away. Greater than, shade to the right. I think this is going to be a pretty large probability. And I'm going to write down what I'm going to type in my calculator. And this is what I want you to do on your labs and tests too. That way, if you type something wrong and get a wrong answer, I'll know that you knew what you were doing and I'll be able to give you a lot of partial credit. So, back into the distribution menu. Minus 2.09, this time all the way to the right, so 10 to the 99, kind of fake out an infinity. And then there's my probability, 0.982. 26. Between 1.37 and 2.25. All right, well, this is what normal CDF is actually designed to do. .37 and 2.25, just both on the positive side. So I'm looking for this area under the curve. So I'll be using normal CDF. And I must have typed something wrong. Well, let's see what it was. Let's see. I hit the wrong button there. Normal CDF, not normal PDF. I'm not going to be using normal PDF at all. 1.37, comma 2.25, comma the mean, comma the standard deviation. Now we have it. So 0.73 is our probability. 7.3% of the bone density scores are between those two values. We have 2 more problems to do here between 28 and 30, and then we'll try 38 and 40. So number 28. Between minus 0.45 and minus 2.08. All right, well, minus 2.08's, again, pretty far away. Minus 0.45 would be here. All right, second distribution down to normal CDF, minus 2.08, comma, minus 0.45. The mean and the standard deviation. About 30% of the bone density scores are in that region. The author wrote these on the page backwards from the way we needed to enter them in. I'm pretty sure that was written there just to see if we were paying attention. I want to show you something. Let's see what happens if I'm not paying attention and I just blindly type in those values backwards. Well, I got the same number I got before, but it's got a minus out front of it because I changed direction. Instead of reading from left to right, I read from right to left. And in mathematics, if you change direction, it comes with a minus sign. But we know probabilities are always positive. So if you ever see this, it means you wrote the bounds in the wrong order. And it actually tells us what the answer is because we just need to take the minus off. All right, one more problem here, and then we'll go down and do 38 and 40. Between minus 0.77 and 1.42. All right, the mean's in the middle. Minus 0.77 below the mean. And 1.42 above the mean. One standard deviation above the mean is right where the curve kind of changes shape. And so that's kind of how I'm trying to, do these somewhat to scale. So, normal CDF minus 0.77, comma 1.4201. And again, for normal CDF, if I don't type in 0 and 1 for the mean, it's going to assume that anyway. I'll demonstrate on this one that I can leave those off and it'll give me the same probability. I don't want to type them in most of the time anyway because that's how I do any of the other problems we'll see in 6.2. All right, so we've seen answers for the problems between 18 and 30 even. Let's do 38 and 40, and that'll be all the examples for today from section 6.1. All right, 38 and 40. In exercises 37 through 40, assume that a randomly selected subject is given a bone density test. Bone density test scores are normally distributed with a mean of 0 and a standard deviation of 1. In each case, draw a graph and then find the bone density test score corresponding to the given information. Round results to 2 decimal places. Okay, so in number 38, we're asked to find the 15th percentile, p sub 15. And furthermore, it just goes on to tell us this is a bone density score that separates the bottom 15% from the top 85%. Well, the mean's right in the middle, separating the bottom 50 from the top 50, so the bottom 15% is down here somewhere. And I'm only going to shade the amount to the left because that's what inverse norm requires in the calculator. Normalcdf, which we've been using, finds probabilities given a left-hand endpoint and a right-hand endpoint. Inverse norm takes in that area to the left and gives us back the data value. So I'll type in that area to the left, and if I just type that in and press enter, I'll get a good answer because the calculator assumes the mean and the standard deviation are 0 and 1 if we don't tell it what they are. In chapter 6.2, we'll have to type in the mean and the standard deviation, so I like to go on and do that most of the time anyway. And that way I'm treating all the problems the same and I never forget to type in the mean and the standard deviation. All right, so that is the actual data value that separates the bottom 15% from the top 85%. That is the 15th percentile. We were asked to round that to 2 decimal places, so minus 1.04. All right, number 40 asks us to find the 3 quartiles, Q1, Q2, and Q3. Well, Q1 is the 25th percentile. So the mean's right there. 25% of the data may be somewhere like there. Excuse me, the value that bounds 25% of the data to its left is right there. That's the first quartile. Q2, well, that's the median. But in a bell-shaped distribution, it's also the mean, so I don't need any calculations for that. I know the mean of 0 is right in the middle there. No calculation required. It's like we get that one for free. We're told to round 2 decimal places, so I'll just write 0.00. Q3 is the 75th percentile. So that'll be the data value that bounds 75% of the data to its left. We're looking for that data value with 75% of the data to its left. All right, well, we can use inverse norm to find those probabilities. We first need to type in a 0.25. We then need to type in inverse norm and a 0.75. And then we'll round to 2 decimal places as requested. All right. Nice symmetry going on here. So the 75th percentile is 0.675, and the first quartile is minus 0.67. All right, well, those were the problems I wanted to do out of section. There's a third quartile, sorry, I was right off the bottom of the screen and didn't realize it, But those are the problems I wanted to do out of section 6.1, so that's it for now.